David Smith here with one more Flip Classroom math video. 3 tips before you start. First, you can speed up or slow down the playback if that helps you get through the video at your own pace. Second, you could pause the video at any time to catch up with your notes. Third, you can turn on the captions and watch my words go by on the bottom of your screen. Today's topic is factoring and solving trigonometric equations. Now this is pretty tricky, and so far in my class this has been buried in bigger lessons that cover more stuff. And so based on your feedback, I realized that you might appreciate a quicker little video that just focuses on doing this type of problem. So here we go. I've got one. 6 sine squared x plus sine x minus 2 equals 0. Now your clue that you need to factor and solve like a quadratic is that you've got your squared term, your regular term, and your constant term. So this actually is a quadratic equation in disguise. We've got the sine x in there that makes it look a little strange. So our first step is to do a little substitution. So I'm just going to write sub, and I'm going to do sine x, which is what we have, and I'm just going to put regular old x in there, and we're going to see what that looks like. So if I take sine squared x and substitute x, I'm going to have 6x squared plus x, because I'm substituting x for sine x, minus 2 equals 0. Now, this looks like a quadratic. And when you had your algebra class, you solved these quadratics all day long. Now, if you remember your technique, when you have a number besides 1 in front of the x squared term, you use splitting the middle term. And so what we do with that, I'm going to do a quick review of that, is we multiply, remember this is ax squared plus bx plus c. We multiply a times c, and we get that number. So the AC is negative 12. That's a times c. Now what we look for is 2 factors of negative 12 that add up to the b term, which is 1 in this case. So 2 factors that multiply to negative 12 that add up to 1. And what those are going to be is they're going to be 4 times negative 3. 4 times negative 3 is negative 12. 4 plus negative 3 is positive 1. I'm just going to split this middle term using 4 and negative 3, and it'll look like this. I like it that the 3 and the 6 have common factors, so I'm going to put it like so. Here's my 6x squared minus the 3x, because these have nice good common factors. Then I have my plus 4x, and finally my minus 2. So minus 3x plus 4x is the same as plus x. I've just split it up, so I haven't really changed my equation. Bring down my equals 0. Now I factor each pair separately. So my greatest common factor in here is going to be 3x. What's left is 2x minus 1. So when I factor the 3x of these two out of these two, I get 3 times 2x minus 1. Now this one, my biggest factor is going to be a 2. So I have a plus 2 coming out, and what do I get back in there? Take 2 out, I've got 2x minus 1 right there equals 0. So now I know I've done this right because the parenthetical factors, these 2 terms, are the same. They have to be for this to work. If they're not, you need to go back, you did something wrong. Okay, so now what I do is these 2 guys become one factor, 3x plus 2, and then this one is the other factor, 2x minus 1 equals 0. And so now we have factored this quadratic. So now we need to substitute again. So we can go backwards. Now we're going to take the x that shows up here and we're going to replace it with sine x. So I'm going to write sub again, because that's what we're doing, and I'm going to get 3 sine x plus 2 times 2 sine x minus 1 equals 0. So there you have it. So what we've done is we've done this first step in this lesson is we've taken this trigonometric equation, we did a substitution, so we made it look like a regular algebraic quadratic, and we split the middle term to factor it. We got all the way factored, and then we substituted back so that we have our sine x in our equation, because now we need that, because solving this is a little different than solving a standard algebraic quadratic. So I'm going to go ahead and bring that over here. Now, when you solve a quadratic and you have one term times another, we use what's called the null factor law or the zero product property. We set each term equal to 0 and solve, and that usually gives us two solutions. We might get even more with this problem. So our first one is 3 sine x plus 2 equals 0. So that's 3 sine x plus 2 equals 0. Then we get 3 sine x equals negative 2. Then we get sine x equals negative 2/3. And then finally, sine inverse of negative 2/3 equals x. So x equals, and you can pull out your calculator and do that calculation right now. So when I do that in my calculator, I get minus 41.8, don't forget our units, degrees. Okay, so that's solving this one. Now we have to go back and solve this other one and see what we get there. So this one is 2 sine x minus 1 equals 0. So add 1 to both sides. 2 sine x equals 1. Divide by 2. Sine x equals 1/2. Take the inverse. Sine inverse of 1/2 equals x. X equals, go ahead and get out your calculator. So now, in this case, we get x is 30 degrees. Okay, we're not quite done. Usually in a problem like this, it will also start in the beginning by telling you a range of values. So let's say for this one, we were given 0 less than or equal to our x, which is less than or equal to 360. So what this is telling us is it's looking for all the values where whatever angle you put in, you're going to get these numbers that we solve for in here. So we need to check and make sure that we've got all of those. Right out of the gate, this one, it's not in this range. This is minus 41.8. This is saying it's got to be bigger than or equal to 0, less than 360. Okay, so here is my way of doing this. I'm a visual guy, and I like drawing unit circles. If you memorize the relationships for equivalent angles for sine, cosine, and tangent, you can just go there, pull that out of your memory, and use it. I like the unit circle because then I can solve lots of problems if I understand how to use it. It's a great tool. So here's my unit circle. And I'm going to mark 41.8, minus 41.8. So that's going down this way, 41.8 degrees. We've come down like that. We are talking about sine, okay? So this whole equation is all about sine. Sine is the y value, or the up and down. So this value here is that, right there. We've come down that much. Now, this one's not in our range. So what one is in our range? Check this out. If we start at 0, you have to go positive. There's 180. If I come a little bit further down, then right there, I have the same value. I'm at the same y level in the negative land. So that angle is this one here, and this is also 41.8. So this first one is 180 plus 41.8 degrees. And that is the value. So this is 221.8 degrees. So that's the first angle in 0 to 360. Now pause the video and figure out the second one. So this one is going to be 360 minus 41.8, because if we go all the way around, we're going to go back 41.8 to get us at this level on the graph, on the y level of the graph. So that gives us our two angles, 221.8 and 318. So those are two angles that satisfy our equation, our very beginning equation. However, we're not done, because we had this equation that was a solution. It generated two answers. Now we also have this equation. We have x equals 30 degrees. So I want you to pause the video, maybe make another unit circle, and figure out what values you get for that. All right, so here's my unit circle. My solution is 30 degrees, so we've come 30 degrees in the counterclockwise direction. This is a valid answer to our problem because it is within this range from 0 to 360. So that one does count. Now as we go around the unit circle, we're going to go up, up, up till we get to 90 degrees, and we're going to come back down, and eventually we're going to hit this same level. In this case, y is positive, it's higher up, so we're at the point where this 30 is the same as that 30. So, but measuring that angle from the start, from 0, it's going to be 180 minus 30, which is going to be 150. So the two other answers for this are 30 degrees and 150. So it's kind of interesting. This equation right up here, 6 sine squared theta plus sine theta minus 2 equals 0, has 4 solutions. There are 4 angles that when you plug them in there, you're going to get 0. Now that you've watched the video, take a moment to jot down any remaining questions so you can ask them in our next class. If you want, you can come back and watch the whole video again if that helps deepen your understanding. If you enjoyed the video, please click like or subscribe.